Oh, there we go. Okay, so the notebook that we're working on today is called expansions. So when you type in something at the bash prompt, when you press enter, the shell does 7 things before it actually tries to interpret your command. Right? And so the 7 things it actually does are these 7 things right here. Right? So these are called the expansions that the shell tries to, that the shell performs on the text that you typed into the terminal prompt. Right? So the first thing that happens is something called brace expansion. So we're going to look at that in a second. The second thing that happens is this thing called tilde expansion. So we've seen that already, right? So when you write tilde, you know that that's just shorthand for your home directory. Right? And so that's actually the second thing that happens. So when the shell sees a tilde, it replaces the tilde with your home directory. Then there's something called parameter expansion, then command substitution, arithmetic expansion. And it's not until those things are all done that the shell actually tries to split what you typed in into separate words. Right? So wherever there's a space or white space, the shell splits the shell splits the input at those spaces, assuming they're not quoted. And finally, the last thing that happens is file name expansion. Right? So whenever you use a wildcard on the command line, the very last thing that happens is that that wildcard gets expanded to whatever it matches. And so the order that those expansions are shown to you, that's the order that the shell actually performs the expansions in. Right? Now, most of these we're not ready to, 1, 2, 3, parameter, command. So parameter, command, and arithmetic expansion, we're just going to look very briefly at those today. We're going to use them more when we talk about bash scripting, which is actually the next lecture. Sorry. Okay, so if you're in the notebook, you should be in this directory called scripts expansions. So I'm just going to run that. All right. First expansion, which is new to us today, is called brace expansion. Okay, so brace expansion is a mechanism for generating a bunch of different strings where the strings follow a pattern. Right? So when you write down a brace expansion, you're going to use braces. That's why it's called brace expansion. And now the form or the pattern that you can write down starts with a string. Right? So it's some string, then there's the opening brace, then there's some expression, there's a closing brace, and then there's some other string. Right? So the string in front is called the preamble. The string at the back is called the postscript. Right? Both of those are optional, so they don't have to be there. Now expression is either a comma separated list of strings, right? So string, comma, string, comma, string, comma, string. Or it's what's called a sequence expression. So I'll show you what all those are in just a second. Okay, so basically the way this expansion works is it generates a string that starts with pre, then it takes something from inside the expression, and then it ends it with post. Right. Okay, so let's look at the very first one. Right? So there's no preamble, there's no postscript. Right? Instead, there's just a comma-separated list of strings. Right? And so the way that brace expansion works is it takes each string from inside the braces, and that becomes one of the strings that are produced. Right? So it's going to take the A, it's going to produce the string A. Then it's going to take the B, it's going to produce the second string B, and it's going to take the C, and it's going to produce the third string C. So if you run that, you get A, then B, then C. Right? Notice that it's separated with a space. Okay, if you have a preamble, or if you have a postscript, then the preamble gets added to the front of every generated string, and the postscript gets added to the end of every generated string. Right? So here I've got a prefix before underscore, and I've got a postscript underscore after. So all the strings are going to start with before underscore. They'll end with underscore after. Right? And then it's going to take one of the strings from inside the brace, right? One at a time. So this will generate 3 strings, right? Before and after, then before ampersand after, and before also after. Right? Notice that for the ampersand, right? Remember the ampersand is special to the shell, so I have to escape it or put it in quotes in order to use it as a string inside of my brace expansion. Right? If you want to see what happens if you leave it off, just take it off in the notebook and run the, right? And you get something weird, right? And something bizarre happens. I don't even know what that means. Let me run it again. I think if I run it again, I'm going to get something slightly different. Okay, no, I don't. Okay, so you get something strange happens. You'll probably get something else if you run it from inside the terminal. Right? It's important to note that when you run something from inside Jupyter, it doesn't always give you the exact same result as if you'd ran it directly from the terminal. Okay, but you don't get the expected result here. You don't get the expected result because the ampersand is significant to the shell. Right? There's a hint here of what's going on right there. Right? So sometime after class, try to work out what's gone on there in that poorly formed expression. All right. You can also have what are called ranges inside the braces. So a range is just, it has the form starting value, then dot dot, end value, dot dot increment, where increment is the value that you want to step by. So x and y can be integer values, right? Or interestingly enough, they can actually be single characters. So we'll look at an example down here where they're characters. Right? So 0 dot dot 9 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So not surprisingly, that's going to give you 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? If you slap a preamble in the front, let's say A, and you slap a postscript at the back, right, then it sticks an A in front of every string, and it sticks a Z at the end of every string. Right? So you get A0, Z, A1Z, right, and so on and so on and so forth. You can go backwards without specifying a negative increment. Right? So it's smart enough to know that it's you want to count down in this case. If you want to count in an increment other than 1, just specify the increment. Right? So here I'm going to count from 10 to 20 in increments of 2. Right? You're allowed to use a single letter as the increment. Right? This would be useful if you're generating file. You want to generate a bunch of files that end in A, B, C, D, E, F, G, and so on. Right? Or start with A, B, C, D, E, F, G, and so on. Right? So here it'll go in increments of 1. So A, B, C, D, E, F, G. Right? It'll go in increments of 1 letter. Right? And similarly, you can go in increments of 2 letters if you wanted to. Right? So this will generate A through Z, skipping every second letter. Right? Now, you might wonder why you'd want to do this. Right? So it turns out there are some certain constructs that follow a pattern that you can create with a brace expansion. One of the most common ones are dates. Right? So it's pretty easy to generate a bunch of directories or a bunch of files that are named using some sort of date format. Right? So here, I'm going to generate a bunch of directories where the directory name starts with the year, right? 2019 up to 2022, right? Followed by a hyphen. Right? Now I've got a second brace expansion, so the month would be a month between 0, 1 up to 12. Right? Notice that you can use a 0 in front of the at the beginning. You can use a 0 in your increment expression, in your, range expression, and it will automatically insert the 0 for you. Right? So if I run that in this directory, you end up with the following directories. Right? And so you can generate a whole bunch of directories by date and month. Okay, similarly, you might be in a situation where you need to create a bunch of files where they all start with the same name. They all start with the same string, right? So they all have the same preamble. They all have the same postscript, right? So I want to create a bunch of text files, right? But I want to number the files from, in this case, 0 through 30. Again, using a brace expansion, this is trivial to do, right? And there you go, right? So you can see there's a whole bunch of files, file 00, 01, 02, up to 30, right there, right? And so if you're generating sequences of files or directories that have some sort of pattern to them, then a brace expansion might be the thing that you want to do. Right? Similarly, if you want to iterate over all of the directories or files that have some sort of pattern, a brace expansion would be one way to generate the file names that you need to iterate over. And then finally, if you read the bash manual and you look at the section for brace expansions, you'll see this expression here. So this expression here contains nested brace expansions. Right? So notice the green brackets here. So that's the start of one brace expansion. Inside, you've got a brace expansion, right? And you've got another brace expansion. And if you look carefully, there's actually a third brace expansion sitting in there, right? So what you've got here is this expansion, right, comma, this, right? And inside, you've got that expansion there, and you've got this expansion here, right? So if you run this, you'll see that it generates the following strings here, right? And again, you should just sit through this. You should just work through this example by hand sometime when you've got some free time, right? And figure out how exactly what this is doing. Okay, so tilde expansion we've seen already, right? You know that tilde just expands to your home name, to your username. It expands to the path, the absolute path of your user, of the current user, right? So if I run that, that's going to do home CISC220 because that's the username on this computer, right? Similarly, if you have multiple users on your system, then you can specify the user's home directory by saying tilde followed by the username, right? There's only one user on this computer, so I can only do tilde CISC220 on this computer, right? But if you're on a system with like 10,000 users, then you can do tilde username, and that will give you that user's, that will give you the absolute path name of that user's home directory. Okay, so parameter expansion we haven't seen yet. It's got a whole notebook dedicated to it. So we'll look at parameter expansion in a minute. Parameter expansion is basically how do I use a variable in bash, right? And you might wonder, why do I need a whole notebook on how to use a variable in bash? And the answer is it's because it's complicated in bash, right? So you're going to see that using variables in bash is not so straightforward. Okay, command substitution. Now, we've used lots of commands, right? So we've generated a bunch of commands. So we use like ls and pwd and cowsay and things like that. We know that those commands generate, a lot of those commands generate text as their output, right? And so you might want to ask yourself, can I capture that output and store it in a variable? And the answer is yes, you can capture that output and store it in a variable. Or you can capture that output and use that as part of another command, right? And so command substitution has the following form. So there's a $sign. Now, the $sign is going to show up all over the place shortly, right? Within a lecture or two, suddenly this $sign is going to show up everywhere. So you have to get used to this $sign appearing. You also have to get used to where you need to use the $sign and when you should not, right? So in a command substitution, you always use the $sign. Round bracket, closing round bracket, command goes inside. Incidentally, if you double click on one of these cells, it shows you the text that's actually in the shell. This is, so all the text in a notebook is written in a language called Markdown. Markdown is just a, I guess the easiest way to think about it is a simplified form of HTML. So if you ever double click and you get something weird, just run the cell and it will render it as HTML. Okay, so what happens when you write this sort of thing here? So what happens is, the command gets run, right? So whatever command you have in there, it runs, right? The result of that command then gets replaced, then substitutes for wherever this is in your, for wherever that is, right? So the command runs in a subshell. Standard output of the command gets substituted for all of that, right? So if you had the cowsay program, right? So in here, if you had cowsay hello, then the string that gets generated by cowsay hello gets substituted for $ round bracket command round bracket, right? In that case, that's not, well, I mean, that would be useful if you wanted to store that string in a variable, for example, right? So here's an example. This website, by the way, is quite useful. So if you go to, the URL name's not that informative, mywiki.woolwich.org. It's actually one of the bash, it's the bash FAQ. And that turns out to be very useful if you're programming in bash. So whoever wrote this website has this section on command substitution. You can read that whole web page if you want to know more about command substitution. And there's this example here, right? So the date command in bash prints the date, right? Plus %a does something, well, let's see what it does. So date plus %a, right? Date plus %a. Oh, date. Well, let's just run date first. So date prints out the current date. It prints it out in a very specific format, right? So the day, the month, the day of the week, the day of the month, the year, the time, and then the time zone, right? If you write date plus %A, did I do it right? Oh, if I write date plus %A, right? And then you just get the day, right? And you get the day in long form. Now, if you're on a Mac, your date command is different than the bash one. So I don't know if the Mac one gives you the same output. Right? Does it? OK, that's good. So that prints out the day. Now, plus %H colon %M, that's going to give you the hour and the minute of the time. Right? So when you run this command, right, date plus %A runs, that gives you Wednesday. Right? And then date plus %H colon %M is going to give you something like whatever the current time is, right? So the result of the date command gets substituted for all of this, right? And the date of this and the result of this date command gets substituted for all of that, right? So it's if you run a command and you substitute the output of the command for the % blah 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 blah. Sorry, for the dollar blah 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 blah. So when you run that, you see today is Wednesday, it's 1446. Right? So the output of the command gets substituted for the command substitution construct. Right? Again, we're not going to use this so much today. We're going to come back to that when we start writing bash scripts. Similarly with arithmetic expansions. So an arithmetic expansion lets you do integer arithmetic in bash. Right? So again, $, now 2 round brackets, right? Followed by some arithmetic expression, followed by a closing, oh, there's a missing closing round bracket, sorry. If you got your notebook, fix it, because that closing round bracket has to be there, right? That will evaluate an arithmetic expression. So it'll compute the result and then substitute the result for all of this. Right? Now bash can only do integer arithmetic, so you can't do floating point arithmetic in bash. Right? If you need to do floating point arithmetic in bash, you probably shouldn't be writing bash. You should be writing something else. If you really need to do it in a bash script, you have to call some program that knows how to do floating point arithmetic and then get the output of that program. Right? So you're going to use a command substitution to do that. So bash is really only equipped to do integer arithmetic. So here, I can compute 1 plus 1 and echo the result. Not surprisingly, it's 2, right? So again, right, $ round bracket, so it treats this as an arithmetic expression, just evaluates the result, substitutes the result for the entire arithmetic expansion. Right, so you get 2. Here's a silly example. I'm going to make a directory dir10. Right? Why you would ever do this, I don't know. Right? But you can. So if I do that, I've made too many files now. Oh, there it is. There's dir10. Right? So you can, in fact, do this. Now, you might have noticed arithmetic expansions directly on the command line. Probably not that useful. And that's true. Right? You almost never do an arithmetic expansion directly at the command line. However, it's very common to do with inside a script, right? So if you want to loop over an array, or if you wanted to count up to a loop that ran a certain number of times, an arithmetic expansion is one of the ways to go. Okay, word splitting. So we've seen word splitting already. You know that whenever you type something into the bash prompt, wherever there's a space, bash separates bash separate whatever on the prompt wherever there's a space, right? So it separates them into separate words. That's called word splitting, right? You know that if you quote, then word splitting is suppressed, right? It doesn't happen. Or if you escape the space with a backslash, again, word splitting doesn't happen, right? Now, if you don't do any of those things, word splitting happens. So there's a file called CISC220 assignmentsolutions.zip in that directory, right? You can see it up here, actually. Right, so there it is. Notice that when you print it out using ls, bash, the shell quotes the expression to indicate that it really is one file. Right? The single quotes are not part of the file name. Right? The file name really is CISC220 space assignment space solutions.zip. right? So if I try to unzip that file like that, it doesn't work. Why doesn't it work? Because bash splits that string into 4 separate strings, right? So it splits it into CISC220, then into 3, then assignment, then solutions.zip, right? So then it passes these 3 strings to the unzip program. So unzip tries to unzip the file CISC220, but that file doesn't exist, right? It tries to unzip the file assignment, but that file doesn't exist. And it tries to unzip the file solutions.zip, that file doesn't exist. So when you run it, right, it complains, right? I can't find or open CISC220, CISC220-zip, or CISC220.zip, right? It doesn't even get past the first argument in this case, right? How do you fix it? You have to stop word splitting from happening, right? So to stop word splitting from happening, quote the entire thing. You actually don't have to quote the entire thing. You only have to quote up to where that last space is. This surprisingly works. It doesn't look like it should work. It does work, right? It actually complains that it's not a zip file. It's not. I just made an empty file called this, right, and said it's a zip file. It's not actually a zip file, right? That actually does work. So you don't have to quote the entire thing. You only need to quote where the spaces are, right? Probably makes more sense to quote the entire thing, though. And run it again, you're going to get the same output, right? It's not really a zip file, right? So that's word splitting, right? You always have to keep in mind that word splitting might occur, right? And you have to quote appropriately. Okay, finally, the last expansion that happens is file name expansion, and we've already seen that, right? So whenever you use a question mark or a star or the square brackets, right, the shell will try to match that expression to some file, to whatever files are in the current working directory, right? That's the very last thing that happens. Right? So keep in mind that whenever you're writing something in bash, right, write down some command, a whole bunch of things happen, right, before that command actually runs. All right, any questions so far on the expansions? We're going to look at the ones we haven't seen so far. We're going to look at over the coming next few lectures. Any questions? All right. So the next notebook is Introduction to Bash Scripting. All right, there's something you need to know. So I think a lot of you are on a Mac, right? So there's not an insignificant number of you on Macs. Now the problem with Mac is the bash that comes installed on your computer is a very, very old version. So it's 3 point something. The current version of bash is 5 point something, I think. And there were a lot of changes from 3 to 4, and then more changes from 4 to 5, right? If you installed Homebrew and then installed the core software, you have a second version of bash. The problem is it's not in the directory user bin, right? So all of our scripts, you're going to see, so not in the directory root bin, sorry. So you're going to see this in all the scripts that I write. Right? So all of the scripts that I'm writing start with hashtag !bin/bash, right? That's the name, that's the full path name of the bash program that's going to run this script. Right? If you're on Mac, you're going to run this script with the old version of bash. So some of the scripts that are in the notebooks aren't going to work properly for you. So the way to fix this on a Mac, or if you just want to change all your scripts, even if you're not on Mac, you can change whatever I have. Sorry, I forgot my mouse again, and scrolling with the keyboard is, with the trackpad is very awkward. So if you're on a Mac, you can change your scripts so that they look like that instead, right? So if you put in hashtag !/user bin env space bash, that will find your homebrew version of bash, which should be bash 5 or 4 point something or 5 point something. Right? Unfortunately, you have to change all the scripts that I've written, which is going to be a bit of a pain in the butt for you guys. But if you find a script that doesn't quite work for you or doesn't do what the notebook says it does, it's because of this problem. Right? And change the start of the script to that, and that will address your issue. Right? At least it fixes the issue on my Mac at home. I don't know if it's going to fix it on everybody's Mac. I'm pretty sure it will. Okay. Okay, so what's a bash script? A bash script is just a bunch of bash commands written in a text file. That's all it is, right? So just like a Python program starts with a line of Python that you could have typed in at the Python interpreter prompt, right? A bash script is just a bash program where each line corresponds to some sort of bash construct, right? The way a bash program runs, it runs the same way a Python program runs. It starts with the first line of code, right? And it steps through each line one at a time. So a bash shell script is just a plain text file, contains a sequence of commands, right? How do you create it? You just open up a text editor and go and write the file, right? If you have the virtual machine, then Microsoft Visual Studio Code is installed for you. You just type in code and then enter, and it'll start up for you, right? So there is an example of a bash script, right? First line starts out with this hashtag !bin bash, right? Then I've got something that starts with just a plain old hashtag. So it turns out a hashtag in bash is a comment, right? So it's the equivalent of a line-ending comment in Python or Java, right? In other words, it's equivalent to / in Java. It's equivalent to the % in Python, right? So this script does nothing. It's just got 2 comments in it, right? If you run the script, nothing happens, right? No output's generated, no error is generated, right? If you wanted to make your own script, you just create a new file, right? So file, new text file, right? And then you just start typing. So your very first line is always hashtag /bin /bash, right? If you're on Mac, it's something slightly different, right? And then you start typing in some bash commands, right? So I can type in cow say hello, right? And there's my bash script, right? What does it do? It runs the cow say program. I can save it. So when you save your program, right, a common extension is .sh, but that's not universal, right? So I'm just going to make, do I have one? No, I'm just going to call it cow.sh, right? You don't have to call it .sh. It's just, if it is called sh, then programs like Visual Studio Code will recognize that this is the shell script, right? Save it. There it goes, right? Okay, so now that I've got my script, you can run the script, right? Now that I've got my, there we go. No, now that I've got my script, I can run my script. Hang on. Why won't you? It's all right. Okay. Let me change that directory. So that's in Introduction to Bash Scripting, right? Okay, so notice that there's cow.sh, right? Also notice that it's shown in my computer, it's just plain gray, right? And so that's trying to tell you that it doesn't, this is just a regular file. It's not a file that you can run as a command or a program, right? If I do the long listing for it, I can see, right, that in fact the permissions for this file do not include the execute permissions, right? So if I try to run this as a script, it's not going to work, right? So in other words, if I write ./cow.sh, it doesn't work. It says permission denied, right? Why is permission denied? Because I just tried to use that as an executable program, but I don't have execute permission on that file. So what do you have to do? You have to add execute permission to that file. How do I do that? Use change mod, right? Change mod u plus x cow.sh, right? List it again. Now it's in green, right? And you can see that the user has execute permission. Yes?
So are all of bash scripts text files then?
Yeah, they're just text files.
So if they're just .txt and they have an executable
Yep, you can run it. Yeah. Yeah. Sorry?
If you go back to Visual Studio
Yeah.
Code, you didn't put an exclamation mark after the hashtag. Do you need one?
Yes, and it's just because I can't type, that's all.
Okay. Well,
Did I not put it in? Hang on.
I don't think so.
All right, well, let's take a look. Ah, you're right. Okay, so let's see what happens when you try to run it. I actually don't know what's going to happen, so let's try to run it. And, oh, it worked. It actually works, which is magic. It's not supposed to work. Or it's unusual that it works. The exclamation mark should be here.
What does the exclamation mark actually do?
Oh, that's a good question. So That thing right there, right? So hashtag exclamation mark, right? So when a shell sees that, it treats the next argument, the stuff after it, as the name of the shell, of the name of the interpreter that's going to run the rest of this script. Okay, so hashtag exclamation mark. So when the shell sees this, it's going to use this program, /bin bash, to run the program, to run the rest of the script. Right? So it's going to use bash to run the script. You can have other shells installed on your system. Right? In this case, it's telling the shell to use bash to run this particular script. So if you happen to know the name of the other of your other shell programs on your computer, you could run with a different shell. So for example, you can run it with Python instead. So if you happen to know where your executable for Python is, you can write a Python script in the exact same way. Right? So where is Python on my computer? Which Python? Which Python 3? Okay, so user bin Python 3. So let me change my script to that. So user bin Python 3. I'm going to nuke this line. And I have to nuke it with Python, so I have to use the % sign. And now I'm going to print hello. Right. So even though it's still called cow.sh, it's now a Python shell script. Right. So now if I run that, come on, cow. Oh, sorry. My Python's a little rusty. I apologize. There. It is a hashtag, right, in Python? The comment? I don't remember. There. Oh, there you go. Missing. Right. Like I said, my Python's not very good, which is funny because I'm supposed to teach the class on Friday because someone's sick. So we'll see how that goes. There we go. All right. Okay. So now we've got a running Python program. Okay, so after all that, you've got a running Python program, right? So hashtag exclamation mark, the rest of the stuff indicates which interpreter should be used to run the rest of the script, right? Normally in this course, you're going to use bash. Mac users, whatever you do, don't use the Z shell to write a script and submit that as an assignment solution, because that's going to cause all sorts of problems for me and the TAs. Okay. Good. All right, so that's the steps you have to go through to generate one of these scripts, right? Open up a text editor, put in the first line that indicates which program should run the script, type in your commands, save your file, make sure it's executable, and then run the program. Oh, there's something else I forgot to tell you. Okay, when I run that program, if I just type cow.sh, it doesn't work. Right? So when I run cow.sh, bash complains. It says cow.sh command not found. Right? And you say, well, that doesn't make sense. Cow.sh is right here. Right? And so the reason that doesn't work is because the way that the Unix shells work is that there's a variable called the path that stores all the directories that the shell will look in for executable programs. Right? So if I echo $path, right, you get this, where is it? Okay, you'll see that there's a colon separated, right, list of directories. So there's /home CISC220.local/bin. There's user local sbin. There's user local bin, user sbin, user bin, sbin, bin, user games, blah, 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 right? Those are all the directories where bash will look for an executable program, right? The current directory is that, and notice that that directory is not on the path, right? So in other words, when you type in cow.sh, right, bash will look in all of these directories for something called cow.sh, and it won't find it, right? So one way to fix the program is to tell it where, one way to fix the problem is to tell it where is the cow.sh program, right? Well, it's in this directory, so that's the dot, right? Cow.sh, and that works, right? You can also say, well, it's in the directory, well, you could write in all of this, right? So you could write all of that, So CISC, right? You can put in the absolute path, in other words, right? Whoa, sorry, 220 notes, bash, scripts, right? Obviously, you don't want to do it this way, right? But you can do that, and that works, right? But if your program is not on the path, right, then you need to tell bash where that program is, right? If it happens to be in your current working directory, the easiest way is to write dot current directory slash and then the name of the program. Right. The other way to do this is you can add this directory to the path. I'm not going to do that right now. Right. All right. Okay, so in Jupyter, a Jupyter cell will actually, you can actually run a script from inside a Jupyter cell. So that's kind of nice, right? So here's another example of a script. What's this one called? Oh, this one's called fortunecow.sh, right? So this one just calls the fortune program, takes the output, pipes it to cow, say, right, and then uses a moose to print the output, right? So if you run this, I'm pretty sure, does this work? Yes, it does work. Okay, right? And so, so this is it. We're going to die. And that says it with the moose, right? So if you run this again, right, you get a different fortune, and so on and so on and so forth, right? So any command or any pipeline that you want to put, that you could type in from the command prompt, you can put inside a script. Yeah. No, everything's interpreted. Everything's interpreted in bash. In fact, this program here, right, that actually is an interpreter, right? So yeah, so bash is an interpreted language. Okay, now the two programs I've done so far, they're not especially useful, right? They're just, I'm just using cowsay or printing hello or doing something silly like that, right? This little script here is actually potentially useful, right? So this is called makesh.sh, right? So make shell. So this is a little program that makes the skeleton, so the starting of a bash script, right? It saves it as the file temp.sh, right? And then it automatically, and then it sets the permission to that file so that the user has execute permission for you, right? So you can just run this little script, and that automatically creates temp.sh, and that's a runnable script for you right away, right? So in other words, if we actually try to run it, right? So this is make sh. Right? Now if I look inside the file temp.sh, you'll see that it's got the starting line I need, right? It automatically has the, it's got the hashtag $bin bash for me. And if I look at the permissions of temp.sh, right, it's executable, right? So that little script makes the start or the skeleton of a bash script for you, saves it as temp.sh. Right? So that's actually a semi-useful script. Okay, what about some of these constructs that you can use in a bash script? So one of them is comments. Comments are useful, right? So a comment in bash, I guess it's the same as the Python comment, right? It's just the hashtag, right? This, anything that is, any comment is ignored by the interpreter, right? So when the interpreter sees that, followed by something that's not an exclamation mark, it assumes it's a comment, it just ignores that line. Okay, so if you actually run this program, it looks like nothing happens, right? So I can run it from inside Jupyter. I can, hang on. I think my web browser has crashed. Just a second here. Yeah, I think it has. It's done this before. Okay, so let me just go to, we'll just go to here instead. All right, so cat comment.shell. Okay, so there's that shell script. It's just got some comments in it. If I run it, it looks like nothing happens, right? But it turns out in bash, something always happens when you run a command. Okay, so when you run a command, there's a value that gets set. So there's something called the exit value or the exit status of a command. Every command sets what's called the exit status. The exit status is just an integer number between 0 and 255. Okay? A program that runs successfully, so encounters no errors, should always set the exit status to 0, right? Now you might wonder, how do you get the exit status? So it's stored in this funny looking variable $question mark. So if I echo that, it's actually 0. So $question mark stores the exit status of the most recently run command, right? So when I typed in echo $0, it stored the exit status of that. So in fact, something did happen, right? That program, or that command, that program actually set the exit status to 0, right? But that's all it did. The exit status turns out to be important. We're going to look at that in a future lecture. Oh yeah, this thing's dead. It's totally dead. Sorry. And I think it's the browser that's died. Okay. Oh, where'd it go? And I probably have to restart Jupyter as well. Come on. There we go. Yeah, it totally died. Okay. You know what? Why don't we just stop there, and I'll finish this up in the next lecture. This appears to have died very badly.